Hello students, welcome back to Best Academy. Today I'm going to discuss a new topic, new example that is related to polynomial. Now we try to understand how a polynomial shows linear set of polynomial is linearly independent. For example, we have in this example that let the set is for k equal to 0 to 1, we have this polynomial type and this set is linearly independent. Now we try to understand this set is linearly dependent or not. Let's start today's lecture. Before starting it, now we choose this, the set is linearly dependent and we choose some scalars for this. For example, we choose some scalar, let a0, a1, a2 to an are the scalars. If these are scalars, then by definition of linearly independent, we can written as this set in the form of linear combinations. So we can written as a0 p0 of x plus a1 p1 of x plus a2 p2 of x plus and so on plus an pn of x that is equal to 0. Right, so here is p0 of x. We know that the p0 of x is that variable which have the variable power 0. So we can written as this a0 plus, this term will be written as a0 plus a1 into x. So a0 plus a1 plus a2 power x2. The reason is that here is the polynomial that starts from a0, a1, a2. So if you're going to generalize this term, so then we're written as a0 plus a1 plus a2 and so on, an x power n is equal to 0. So if you're going to compare the value from right hand side is equal to left hand side, so the first term, that is a0, is equal to 0. So if you're going to comprise that is basically, this is the comparison on x power 0 coefficients. If you're going to comprise here the power 1, right? So x power 1 coefficient having a0 plus a1 is equal to 0. So if you're going to comparing the value of a2, at that time a0 plus a1 plus a2 that is equal to 0. So in generalizing form, we can written as a0 plus a1 plus a2 so on plus an is equal to 0. And this is the comparison of coefficient when we are going to compare the value of x power n. Here is the comparing the value of n. If you notice that you put this value in this equation, so and we get the value of a1 is equal to 0. So if you're going to put the value of a0, a1, here is 0. Here the value of a2 is equal to 0. So we will obtain the series of scalars, right? So generalizing, then we can written as in the form of a0 is equal to a1, that is equal to a2, so on, that is an is equal to 0. So we get, so it is trivial because the all scalars having value 0. So this equation, let's suppose this is equation number 1. So equation 1 satisfied, equation 1 satisfied. So the given set is linearly independent. So this is the procedure you can prove any polynomial set in the form of linearly independent. Here I have choose a next term of polynomial, right? So in this way you can prove any set of polynomial rather than belong to P2 type, P3 type, P4 type to Pn type. You can easily prove this type of set. Here I'm going to stop my lectures. If you have any sort of query, any sort of question, you give me a comment. I will discuss in next video. Please share, like and subscribe my channel. So see you shortly. Till next video. Bye bye.